types of buffer. Um, okay, we have two types of buffer. First is acidic buffer, and other we have which is basic buffer. We have basic buffer, which we will talk in next video, but today we will discuss about acidic buffer, right? So what happens in, okay, in acidic buffer, basically we need a weak acid plus strong, we want a salt of strong base plus weak acid, right? So in acidic buffer we actually want a weak acid plus a salt of strong base and weak acid. Basically we want a salt of strong base, right? So these are the conditions of a acidic buffer. For example, let's take, okay, basically there are two methods. Okay, these are not like, these methods are not written in any book, it's made by me basically. Okay, there's one direct method and there's another indirect method. Let's look into first direct method, right? So okay, let's take, okay, first, like, we want a weak acid like CH3COOH, right? Plus, okay, we want a salt of a strong base. Let's look into sodium acetate. What about this? Sodium, so this is a weak sodium, okay, this is acetic acid, which is basically a weak acid, and here we have sodium acetate, which is a salt of strong base, right? So these, when these both will combine together in a solution, they'll make a buffer solution, right? So let's look into other examples too. For example, let's have hydrogen cyanide. Hydrogen cyanide plus, let's say hydrogen cyanide is basically a weak acid. Let's have a sodium cyanide, which is a strong salt of, like, it's a salt of strong base. Hydrogen cyanide, which is weak acid. Sodium cyanide, which is basically a salt of strong base. Third we have, let's look into carbonic acid, H2CO3, right? Plus, okay, weak acid is sodium, had this carbonic acid. Let's make a strong base. Let's make sodium carbonate, or you can make potassium carbonate. Let's make potassium carbonate. Okay, when this will form, they'll form an acidic buffer. Okay, because this is the condition of. Let's have an other thing. Okay, let's have benzoic acid. Okay, now what is benzoic acid? Let me draw this. I love to draw things basically. So here we have, it's not, well, this is a ring structure. Over here we have COOH, which is basically benzoic acid. This is benzoic acid. Let me write over here. This is benzoic acid. right? Okay, its salt will be basically potassium benzoate, or you can say sodium benzoate. Okay, let me write over, let me make over here. Salt will be something like it will be COO, right? This is like this. So this is basically a salt, and this, the name of the salt is basically known as, you can say it's known as potassium benzoate, right? This potassium benzoate. So basically benzoic acid is a weak acid, and potassium benzoate is a strong, it is a salt of a strong base, right? Okay, let's look into more, which we have. Let's have, okay, hydrogen fluoride, right? Plus sodium fluoride, right? Then we have hydrogen sulfide, plus you can say we can have potassium sulfide, right? Let's have, okay, we can have multiple. Okay, here we can have carbonate acid, carbonic acid, plus we can have calcium carbonate, right? This is calcium carbonate. So these are what, these are basically weak acid and a and salt of a strong base. This acetic acid plus sodium acetate, hydrogen cyanide plus sodium cyanide, carbonic acid and potassium carbonate, benzoic acid and potassium benzoate, hydrogen fluoride and sodium fluoride, hydrogen sulfide and potassium sulfide, carbonic acid and calcium carbonate. These are what, weak acid and a strong, like the salt of a strong base. Okay, this was a direct method. If I say you, okay, one thing to remember, that buffer solution works on common ion effect. Okay, this is an important thing. I have to write over here. Note one thing, that, okay, we'll study about this. Buffer solution works on common ion effect, right? The buffer solution actually works on common ion effect, and we'll look into common ion effect tomorrow. My video will be on common ion effect. Okay, so what is common, let's give you an overview what is common ion effect, right? So as you can see over here, okay, this COOH over here and the CO, like CH3COO, basically this CH3CONA CO, and here CH3CO, these both are common, so both common. Here we have cyanide, carbonate, this whole ring, and COO, both are same, right? Here fluoride, here sulfur, and here carbonate and carbonate. What are these? Basically they are common ions, right? This is an overview. I will explain you in my next video too about the whole thing. Okay, let's look into the indirect method of this. Basically I have named it by myself, nothing else. Okay, let's have sodium hydroxide plus acetic acid. Do you think that this solution will form a buffer solution, right? Okay, basically you can do any kind of reaction, but you have to find in the last your product must be a weak acid and a salt of a strong base. What will happen, reaction will take place, and sodium, okay, sodium acetate will be formed, plus water will be formed. Okay, here H2O, right? So what is this? In the last, we have this weak acid and a salt of a strong base. But there's a condition basically. There is a condition, and I love conditions. Okay, so there's a condition that this sodium hydroxide must be a limiting reagent. This sodium hydroxide must be a limiting reagent. Now what does that mean? It means that its concentration must be less and this acetic acid concentration must be high. The concentration of acetic acid must be high than the concentration of sodium hydroxide. Right? So the concentration of acetic acid must be higher than the concentration of NaOH. Okay, my spelling is wrong. Okay, I've got this. I hope this is correct. Oh, it's correct now. Okay. Okay, why I'm saying this? Okay, for example, let's have this. Okay, let's consider that the concentration of sodium hydroxide is 0.1, right? And the concentration of this acetic acid is 0.4, right? So in the reaction, basically, what I've done. So, okay, in the reaction, basically, in reaction, 0.1 sodium hydroxide will react, right? And with 0.1, obviously 0.1 acetic acid will react, right? So obviously they will form 0.1 sodium acetate, right? Then obviously in the last 0.3 acetic acid will be remaining, and sodium sodium acetate 0.1 will be remaining, and this sodium hydroxide will get dissolved. It will get dissolved. We won't be having this amount, right? So in the last, what we got a weak acid and a salt of a strong base, so it will form a buffer solution. Okay, now let's take this example. Okay, how this is buffer solution basically. Okay, let's take a container over here. Okay, this is sodium, this is acetic acid basically, right over here. Now what will happen, this acetic acid will also break down the concentration which is remaining basically, which will break down in the presence of water, and it will form CH3CO minus, plus the hydrogen ion will be formed right over here. Now let's take a container over here. Let's take a container. Okay, this is a container, right? And let's put these things into this. What do we have? We have this reaction in which sodium hydroxide plus CH3COOH results into CH3COONA, plus we have water, right? We have water. Now next what we have, CH3COOH breaks down in the presence of water, and CH3COO minus, plus we have hydrogen. This is a solution, right? What, like, we want to test it, does the pH really changes, or does the pH really remain same, really remains fairly constant? Does the solution really maintains maintains a pH? We want to check this, right? So what will happen, let's add hydrogen ions into this. Okay, Okay, let's add hydrogen ions into this. Okay, when we will add this hydrogen ions into this, what will happen? This CH3COO will again will join with these hydrogen and it will form CH3COOH. It will form CH3COOH. This will be formed, right? But what if we add OH ions? And obviously this acetic acid will be formed, right? What will happen? This acetic acid will again break down in the presence of water. Now let's add OH into this. Let's add OH into this, right? Let's add OH into this. Now what will happen when we add OH into this? This OH will basically combine with H positive ions, which were produced when acetic acid dissolved, right? This OH negative will combine with H and they will form what? Water. They will form water, right? So this fresh water will again react with acetic acid and again the acetic acid will be dissolved. So this is how it is becoming. Basically, you will now say that this, okay, we know that this is acetic acid, right? This acetic acid has negative charge and this H ions has a positive charge right over here, right? So this will form a neutral solution. Okay, we know, okay, this is a solution and where we from this reaction we got a strong salt, like we got a salt of a strong base. Now what will happen? This strong, like this salt of strong base will also dissociate. It will also dissociate. It's right here. Basically this reaction should be here. It should be CH3CONA, which dissociates basically into CH3COO negative plus Na, right? Okay, now you're wondering that this sodium has positive charge and does the change the pH? No, because positive and negative will cancel each other and no pH, there will be no change in the pH. Okay, now what will happen? Okay, let's consider this again. Okay, what will happen? Okay, we in a buffer solution we want a weak acid plus a salt of a strong base. We have over here the salt of a strong base and a weak acid. Now this salt of a strong base will dissociate into CH3CO negative and sodium ions, and this weak acid will also dissociate into CH3COO plus hydrogen ions, right? And you will say that will they change pH? No, because they're the positive and negative charge. They both will cancel each other, and no, there will be no certain change in pH. Now, you want to check is there any change if we add hydrogen ions or OH ions, right? If we will add over here hydrogen ions, right? This hydrogen ion will basically react with this CH3COO and it will form CH3COOH, which is basically acetic acid. So acetic acid will be formed. Now what will happen if you add OH ions into this? Now what will happen? This OH ions basically will react to this hydrogen ion and they will form water. Now this again, this fresh water which is produced will react with this sodium, as this is this acetic acid and again dissociate. So again dissociation will be taken place. No, there will be no certain change in pH. So this is what acidic buffer is, as it is not changing its pH, it is maintaining a constant, oh sorry what I did. So pH is maintained fair right? So the pH is maintained fairly. Okay, so I hope this acidic buffer is clear to you. So just part one, and I'll be discussing more about this in my next video. Okay.